Weekend assignment number 3. Fill in the blank to make the following statement reflect the idea of the commutative property. Now remember, commutative property just means you are switching the order around. Signs aren't changing, operations aren't changing, just change the order. So if the order on the left was 23, then y, the other side would be y, then 23. Number 2, the commutative property does not work with division. Prove this is true by creating a problem and solving both sides to show that the commutative property does not work with division. Well, let's do a division problem I know works. 6 divided by 2. I know that is 3. But if I switched it and I did 2 divided by 6, that, you can just use your calculator, is a decimal. That's 0.33 repeating. Not the same answer, so that proves that the commutative property does not work with division. Match the property to the following equations. So if I'm looking at number 3, it looks like what happened is that the order switched, right? I had -7, then 6. Over here I have 6, then the -7. So that is commutative property when you change the order. Number 4, it looks like the order is exactly the same on each side, just parentheses have moved. First it was combining the 2 and the x, then it's combining the x and the 7. So when just parentheses are changing what is being combined, that is associative property. And then number 5, it looks like, to get from this side to this side, it looks like they took this 3x and multiplied it to that 2 and 5, so that is distributive property. Number 6, Debbie solved the following equation. So they have all the steps over here. She made an error between what 2 lines? So it looks like from line 1 to line 2, she moved the 2 over, which it's a -2, so she would have added it, so she did that correctly because 16 plus 2 is 18. Then it looks like from this line to this line, she got rid of the parentheses, and to do that you would distribute. 3 times x is 3x. 3 times 4, though, is not still 4, so this is where she made her mistake between lines 2 and 3, so that would be choice 2. Number 7, which number has the greatest value? I don't know about you, but I do better with decimals. So 1 and 2/3, 2/3 is just 0.6 repeating, so that would be 1.6 repeating, right, because the 1 in front and then the fraction. Square root of 2, I can use my calculator, and that would be 1.414, and that keeps going. Half of pi would be 1.57, keep going. And then 1.5 is already a decimal, so if I look, now it's really easy for me to see that choice 1 was the greatest value. Evaluate. If x is -3 and y is 1/2, determine if the following equations are true or false. So first I have to evaluate. So I'm going to just plug in anywhere I see an x, a -3. Y, I'm going to use 1/2. And I'm going to evaluate the left and the right-hand sides. And then say true or false, depending on what I get. So this one, -3 divided by 1/2 is -6. There is nothing to do on the right. And if I look at that, those two things do not equal each other, so that is false. Number 9, plug in my -3 and my 1/2. Evaluate. So I would do this multiplication first, because you always do multiplication before addition. And then I can do the addition. So -3 plus 2 is -1. There was nothing to do on the right-hand side. And it comes out true. -1 does equal -1. Number 10, plug in your -3 and 1/2. Oop, I don't know why I put a parentheses after that 7. So 2 times -3 would be -6. And then I can also do the multiplication over here. 26 times 1/2 is 13. Now -6 minus 7 is -13. So I get -13 equals 13. Close, but a negative 13 is not the same as a positive 13, so false. And then number 11, again, plug in the negative 3 and the 1/2. So negative 3 is going to get plugged in twice here. Now, deal with what goes inside my parentheses here first. So we get negative 3 plus 6 times 1/2 is just 3. And I can deal with what's inside there. Negative 3 plus 3 is 0. And then negative 3 plus 3 over here is also 0. And I still have to multiply on the left. So that'd be 0 equals 0. Again, same thing, so that is true. Number 12, I have to solve my inequality and then graph it on the number line. So I'm going to distribute. So pretend like it's a regular equation. Don't let the inequality throw you off. So I'm going to move my x. It's a negative 4, so I add it to the 8x. I'm going to subtract the 6. And then divide by 12. And I'm dividing by a positive number. Yes, there's a negative over here, but the number I'm dividing by is positive, so I do not switch my inequality on this one. That's going to stay greater than. So x is greater than negative 2. So I'll put negative 2 in the middle of my number line and count up a few numbers and down a few numbers. And remember, it's an open circle because it's not equal to, and if x is greater than, negative 1 and 0 are greater than negative 2. So I would draw my arrow going this way. Now it says, what is the smallest possible value for x? Well, if I'm looking at my numbers that are shaded in here, negative 2 doesn't count. It's not shaded in. It's everything greater than that. If I'm looking at all these numbers in this direction, negative 1 is the smallest possible value. All right, same thing with 13. I am going to start by moving my 3y over to the 8y on the left. And move the whole number over to the right. And then divide. So again, I'm not dividing by a negative, so it's just going to stay y is less than or equal to 6. So I'm going to put 6 in the middle of my number line and count up a few numbers and down a few. And now this time it is equal to, so the circle above 6 should be shaded in. That's a closed circle. And y has to be less than this, so this direction where my numbers are less than 6 is to the left. And what is the largest possible value of 5? So if I look at all my numbers, or value for x, if I look at all my numbers that are shaded in, 6 is the biggest. 6 does count in this one because it's a closed circle. Y was equal to 6.